So with imaginary numbers, the first thing I want to make sure you realize is when you combine them, you combine like terms just like you'd have an X or a Y or any of that stuff in the middle, or any of the other stuff, any of those other variables we've had. So for number one, this shouldn't be any different. Everyone should be fine with this. When we combine these, I can combine 16 into 12, negative 16 plus 12 is negative 4. And then combine your numbers, the negative 13 and the positive 6. Negative 13 plus 6 is negative 7. I don't care what order you put it in, but that's the order you usually put your imaginary number second. Negative 7i minus 4, I can list that as well. I'm not nitpicky with the notation on this. First way, where you have your real number first, then your imaginary. So hopefully not too bad. Number two, the only difference with number two, remember, you have to distribute that negative first. So you need to make sure you distribute that negative, which means you have 2 plus 3i minus 4 minus 5i. The most common mistake that people do with this is they don't distribute it. They just take out the parentheses. So it's 3 plus 2i minus 4 plus 5i. They just take away the parentheses, so they didn't change anything. Get back here. That's not right. You have to distribute that negative or think of it as a -1. Once you've done that, now we can combine their like terms. So 2 and -4 is -2. 3 and -5 is -2i. Those. Hopefully not too bad. Again, that number 2 to remember. A lot of people get that. All right, go ahead and do number 3 and 4 on your own. I'll give you guys about a minute or so, and then I will call on people. So if you're somebody that the other day when I called on you, you said, I didn't know how to do that one. You need to ask. That's the whole point. I don't like to put people on the spot, so I'm not going to. I'm telling you, I'm going to call on some of you guys. You have some time to ask the person behind you, compare answers, ask me. Do what you got to do. Make sure you double check 3 and 4. Make sure you have the right answers for those. Next thing we're going to look at is the imaginary. So we don't, well, I don't know. These questions exactly like this on the test. But if you grasp this, this is the whole key of what we're doing today. You have, and I'll take a volunteer for this one, the square root of 25 squared, what do you get for that? Exactly. The square root of 25 is 5. 5 squared is 25. Or remember, we talked about when we cancel out square roots, when we were solving for the square root of x, to cancel out, we have to square both sides, right? That cancel out left is x. Well, if it cancels there, it's a squared, it's going to cancel, so left is 25. Square root of 15 squared, cancel, is just 15. So looking at number 7 and number 8. Number 7, you have the square root of -1 squared. So what's that going to be? It's not anything different. What do you guys think? 1. Absolutely, and there are 2 answers, and they're both right. So that cancels, or we're close. That cancels, so it does have -1. So somebody kind of answered it, and it wasn't correct for number 7, but they were on the right page, and I like the way they're thinking. On number 8, we have I squared. What's that going to be? This is a tricky one. Does anyone want to have a stab at it? Be -1, absolutely. Good. Because I is the same thing as the square of negative 1. Well, negative 1 squared is negative 1. Squared got to be negative 1. So again, I is the same thing as negative 1. So if we have I squared, that's the same thing as the square root of negative 1 squared. And that cancels, and so that's why I squared is the exact same thing as negative 1. That is the concept today. That once it clicks, it makes today go a lot easier. That's really the biggest thing for today. I mean, there's going to be some more math that we're going to work with, so this is going to be a little harder than that. But that's the new concept that's got it click. Then the other thing I really wanted to make sure between number 9 and number 10, you guys remember your properties. The difference between quantity squared and 4i squared. 4i in parentheses squared and 4i squared. So with number 9, if they're both in parentheses, you take the squared to both of them. So it's 4 squared and I squared. 4 squared is 16. I squared, we just said, was negative 1. 16 times negative 1. It's negative 16. Compared to number 10 is not parentheses, so the 4 is not squared at all. So it's just 4 times I squared is negative 1. 4 times negative 1 is negative 4. That's the difference. If you have it in parentheses, you need to distribute both of them squared. On parentheses, it's just the I. Again, anytime you see I squared, you can sub it in 1. So even if you don't get this concept, if this makes it easier for some of you, even if you guys don't understand this concept of why I squared is, well, I is the square root of negative 1, so I squared cancels, and so on. If you don't understand that concept, if you can just remember this step right here, anytime I squared, you sub in a negative 1, that's good enough. Again, I would love it if you understood why, but if you can just do that every time, you'll get questions right. So, one big thing with this one. For everything we said, any exponents. You'll never have any exponents with, because if you ever do an exponent, you can write that down. So for instance, if you ever have an answer that has a 5i squared, that 1, so it's 5 times. We will not go into anything that's above I squared. In case you're wondering, it's kind of interesting. I to the first is the square root of negative 1. So I squared. I to the third is negative 1 times, I guess I can write it this way, is I squared times I, which is negative 1 times the square root of negative 1. So it's negative, because 1 negative 1 squared times I squared, which is just positive 1. And then I to the fifth cycles back to square root of negative 1. You don't need to know any of that. If that's confusing, not a huge deal. If you're in the middle of writing that down, that's great. I'm going to erase it because you don't actually need it. But that's, I mean, I don't know if it's a standard anymore. When I started teaching, I had to go through a whole lesson of that. It was really, I mean, it's an interesting thing. It's not possible you guys could all do it. We're not doing, it's difficult. It's something we're not going to get into. So again, you should never have an I with an exponent, because every single time you should reduce it. The good news is our exponents will only get up to I squared, and so again, that's what we're reducing down. Okay, sorry, that was probably an over explanation. Number 11, you do this just like 5, so 5 times 4 is 20, 5 times negative 30i, not too bad. Didn't really have to do anything special with that one. I have ones like that. Ones like number 12, where you have to take 7i and distribute that. 7i times 3 is 21i. 7i times 4 is positive 28i squared. And this is where we're missing stuff. Because they do that, and that's perfect, you do everything right, but they leave that as their answer. That's why I told you can never have an exponent with your I for your answer. You hopefully notice, oh man, I have a square with my I. You can't have that. That I squared you can reduce down. So that I squared is the same thing as 28 times negative 1. 28, positive 28 times negative 1 is negative 28. So really, we have 21I minus 28. If you want to put it in this order, that's fine. I don't care. I personally put the negative 28 first. Technically, that's the notation that's more widely accepted, but that is the basis of what we're doing today. We're doing distribution, we're multiplying things out, we end up with an I squared in our answer, and we have to get rid of that I squared by substituting in a negative 1. Question or stretch? No. No, do not leave it as 21I plus 28I squared. That's the whole idea. We're trying to make sure we reduce that I squared. These next two problems are, I'm hoping, the hardest that's going to be today. Lesson is where you're doing double distribution or whatever you guys learned this to call it. Taking this 2 and then multiplying it by the 4 and the 5, so I have 8 plus 10I. Go back and take the 3I times 4 and the 3I times 5I. 3 times 5 is 15. Remember, I times I is I squared. So once you get that done, now I have to go through and clean things up a little bit. Biggest one, plus 15 times negative. And those, that's plus 22I and 8. So we have 8 plus 22I minus 15. I don't really care how many steps you take, but I am going to definitely look for this in your answer. Then from here, the the 8 plus 22I minus 15, you can still combine. For this, negative 7 plus 22I, or minus 7 is fine as well. Now again, I'm hoping a lot of you guys are like, oh, that's it, that's not too bad. That's what I'm hoping. If not, no, that's fine. Just make sure you keep paying attention for number 14. Make sure you do those 3 you problems, because this is definitely one of those things that I've literally seen it click with people, and they're so confused, and then all of a sudden they do one and they're like, wait a minute, wait, that's it? And it just clicks. So make sure you're paying attention to those. Number 14, distribute 2 times 4, 2 times negative 7I, so that's 8 minus 14I. 7I times 4 is 28I. 7I times negative 7I is negative 49I squared. Now again, that I squared is negative 49 times negative 1, so that's plus 49. Negative 14 plus 28 is positive 14I, and we still have the 8. And again, this is no different than if instead of having I, we had an X. It's no different except for we don't have the X squared. We can keep reducing down the I squared. 8 and 49 is 57, question mark. 57 plus 14I then is what I get for my answer. Any questions on those? All right, go ahead and do 15, 16, 17 on your own, and then we'll move on to the conjugates that we'll talk about. So the next thing we're getting into is called the conjugates. Now, I know that you guys just did some of these on your own. Actually, before I do this, I was going to say, before I forget, just FYI, this 6 plus 3i times 6 plus 3i, I don't know if it'll ever show up, but that's the same thing as saying 6 plus 3i squared. And there is a formula that is deemed a quote-unquote shortcut, where if you have something squared, a binomial squared, you can plug it in this formula. It's the same with any binomial. My only problem is, unless you have practiced and used that formula, I think it's way harder than just foiling it out. So if you ever see something squared, I would just go ahead and write it out twice and then foil it just like you did that last one up here. Now, one of the reasons I say that is because that's very similar to the one we have for number 18. Number 18, instead of being 2 plus 5i and 2 plus again, it's 1's plus and 1's minus. So go ahead and do number 18 on your own, and I'll ask for volunteers, and if no one volunteers, that's fine. But I'll ask for volunteers why that's maybe a little bit of a unique situation. Go ahead, do number 18 on your own quick. Talk about what conjugates mean and what they are and where they're in. Give you about another 30 seconds. And again, don't rush. If you're not done yet, that's fine, because like I said, if there's no volunteers, I'll give you the answer and we'll move on. I don't know if I mentioned we'll have a quiz over this stuff, the last 3 lessons. The functions with the graphs, the reducing radicals and these imaginary, we'll have a quiz on that on Thursday, Friday this week. All right, so as you look at number 18, does anybody want to volunteer and tell me what's a little bit unique about number 18? Well, what about your answer? So having that answer where they're both exact same numbers, just 1's plus, 1's minus, does that affect your answer at all? Look at this one, and maybe some of you guys probably have. What do you multiply this out? 2 times 2? 2 is negative, sorry, 2 times negative 5 is negative 10. 5 times 2 is positive 10i. And then 5 times negative 5i is negative 25i squared. Do this one. Same thing as before, the I squared is negative 1, so that's negative 25 times negative 1, so it's positive 25. Then your 10i and negative 10i cancel. 10 plus 10 is 0, 0i. You have left with then is 4, 4 plus 25 is 20. And that's your answer for this one. So the unique thing about this question is that your imaginary numbers an I, one was a positive 10, was a negative 10, so they cancel each other. The only other I in there was was an I squared, which then you can sub in a negative 1 for that. So the conjugate is something you can multiply with your binomials that will get your i's to cancel. So when I say conjugate, just to make sure we're clear, these 2 parentheses are conjugates of each other. So the conjugate of this one, 5 is 2 minus 5, and vice versa. The conjugate of this one, 2 minus 5 is all you're doing is changing that sign in the middle. Now later on we will do this again. Don't write this down because this is going to go now. I don't know who made the rule where you cannot have a square root in a denominator. Well, an I is a square root, so square root of negative 1. So you're not allowed to have any i's in the denominator. So I don't know if we'll get to this or not. Honestly, for your sake, I hope we don't. Not that it's impossible. It's just a lot of work. But if you ever have like 3 plus 5i in the denominator, we need to figure out a way we can multiply that to cancel out all the imaginaries. We don't want any imaginaries in the denominator. So again, that's just foreshadowing, fun fact. But you need to, or you'll eventually need to, if I give you a binomial, you need to be able to list the conjugate. So 6, 7i, the conjugate is 6. And then I want you to multiply those together and find 6 is 36, 42, times positive 6 is 42, and 7i, 7 times negative 7i, and I squared. Go back and simplify. We have 2i positive 42i that cancels. Times negative 1, so it's positive 49. We have canceled is 36 plus 49 is 85. So for this one, you just got 85 is what you ended with. Again, that conjugate is a way you can completely cancel out all of your imaginary numbers. Same thing with number 20. We have 5 minus 4i, so the conjugate is 5 plus 4i. Just change your sign. That's the only thing that makes any difference. And when you multiply, we have 25 plus 20i minus 20i minus 16i squared. And again, if you have a conjugate, and if you did it all correctly, the whole idea is that those cancel. 16 times negative 1 is positive 16, and then we still have the 25. So you end up with 25 plus 16 is 41. Any questions on those? So you will have some questions on your quiz and on your test, just like this one, where I want to see your conjugate, and I want you to multiply those together. There might be 2 separate questions. One might be multiplying them together. One might be telling me the conjugate, but you will have questions like that. So go ahead and do 21 and 22 on your own, and then you guys can move on your worksheet. I put those 2 answers up there. If you're getting something different, please ask. Because again, as you guys know, I did not use a calculator, and that makes me really nervous. So if there's any mistakes, it definitely can be on my end. So if you got something different, please ask.